We're Project Haiti Water and Energy, Team 4.
I'm Zachary Smalley, computer science major.
Zach Patterson, mechanical engineering major.
And I'm Charles Carpenter, biomedical engineering major.
Basically, the problem is the Good Neighbor Orphanage in Haiti. They don't have sufficient access to clean drinking water for their orphanage. What we're trying to do is research and design an energy system to power a new filtration system for the orphanage.
Just a bit of background, the city of Arcahai, Haiti has a population of 130,000 people. They typically experience weather between 73 and 95 degrees Fahrenheit. They have roughly 8.5 hours of sunshine per day. Haiti is known for having droughts, floods, and hurricanes. The big thing that we had to work around was a major earthquake that occurred in Haiti in 2010 and basically wiped out the country.
Our community partner is the Good Neighbor Missions International Orphanage. They run the Good Neighbor Orphanage. It houses approximately 80 people, including the orphans and the staff who are there.
The desired conditions we want to provide them with are sufficient energy to provide them with clean drinking water, an inexpensive and sustainable solution, a power source that needs to be either a generator or a solar panel for the water pump, and they would also like extra power for laundry and other activities.
Our project constraints, we haven't heard back from our community partner for a while, so we haven't gotten much concrete information. They don't have much money for a budget, so our solution will have to be funded elsewhere through grants and fundraisers. It has to be easy to use and reliable because they don't have very much technical experience. Our tasks are to develop understanding of the requirements, compare research designs, and assess functionality of each. Design chosen energy system and implement the energy system.
Some of the current conditions that the orphanage is facing is that they currently draw water from a well and carry it from over a mile away. They are severely limited by money and the availability of resources. The current site was built to be temporary after the aforementioned 2010 earthquake that destroyed the previous housing the orphanage was utilizing. They use a very expensive gas generator to generate their power currently, and that's not working out for them very well anymore. And as far as buildings, they only have a plywood dorm to house the children, metal buildings for classrooms, and the kitchen and eating areas are both located outdoors.
So the main challenges are that they are currently very limited on money and resources. They have no existing infrastructure such as power grids. They have a lack of technical experience on the ground, and as a group we do not have concrete information on the pump filter because that is reliant on the other groups. This is the current area of the orphanage. As you can see, there's not much. The pump system would likely be placed somewhere in here in this open area.
Some of the designs that we considered were initially some of the more obvious ones like solar panels and gas generators, but we also considered such sources like alternative fuels, stationary bikes that would generate electricity, and wind, but we quickly decided that the last three would not work because the website for the orphanage explicitly stated that they needed either gas generators or solar panels. So this is a matrix we used to come up with the solution that we would utilize. As you can see, we broke the criteria for the solution into 4 different categories: cost, durability, maintenance, and power production. We assigned each category a weight, and then we rated each of the 3 solutions on a scale of 1 to 10. We did this and found that the solar panels to power the pump only, meaning no extra amenities, would be the best solution going forward. Our current budget is at about $1,400. This would include 4 $300 solar panels, 4 $40 mounting brackets for the solar panels, and about $50 for additional components such as wires, screws, and any other small miscellaneous items that we really are too small to itemize individually, and then an additional estimated $15 of labor for installation. These are simple mock-ups of our prototype that we have so far come up with. We've worked closely with another group to conceptualize a design. So as you can see from these pictures, we would have a building constructed that would house the internal pumps and filters. It would additionally have a tank inside that would store the water. And on top of the building, we would have our solar panels that would power all the internal mechanisms for the water pump.
Going forward, next semester is going to build, retest, refine a physical prototype. We're going to finalize our budget and expenses, and firm up the specifications of the solar panels based on their needs, and none of us will be returning for next semester.
This is Haiti Water and Energy 4. Thank you for watching our video, and good luck in the future.